Let us continue with properties of determinants. So here in the first question we have to prove this determinant is equal to AQ plus BQ plus CQ minus 3ABC. We know one of factors of AQ plus BQ plus CQ minus 3ABC is A plus B plus C. So starting from left hand side, we change R3. We add to elements of third row, elements of the first row. So that we have A plus B plus C here, A plus B plus C here and here. That's R3 changes to R3 plus R1. So first of all, we write elements of those rows where there is no change. First row, second row. This is A plus B plus C, same here and here. Then taking A plus B plus C common, and inside we are left with A, B, C, and then A minus B, B minus C, C minus A. This is 1, 1 and 1. So once we have ones, we subtract ones to get zeros. So for that we change C1 to C1 minus C2 and C2 to C2 minus C3. So writing A plus B plus C outside, this is A minus B. Okay, this minus this is A minus 2B plus C, and 1 minus 1, this is 0. Same here, B minus C, this will be B minus 2C plus A, 1 minus 1 is 0. Now we have two zeros and this is 1. So we expand along elements of the third row. So it's A plus B plus C. It's this product. This is B minus C. Then A minus 2B plus C. And this is A. Let's write A plus B plus C. It's AB minus 2AC plus A square minus this is B square plus 2BC and minus AB. And minus this product, which is AB minus AC minus 2B square plus 2BC plus BC and minus this is C square. So A plus B plus C, this is AB minus AB, this will cancel out. So, and here we have AB, this is 2BC. Let's write A square. Then we have minus B square plus 2B square and plus C square. Then it's minus 2AC plus AC is minus AC, 2BC, and this is BC. This will cancel out, so we'll be left with minus BC. So AC, BC, and this is AB, minus AB. So that's A plus B plus C into its A square plus B square plus C square minus AB minus BC minus CA. And this is same as the right hand side. You know, factors of this are this and this. This is how we prove it. Let's move to the second question. Here we have to prove left hand side is equal to A minus 1 whole cube. The first step is how to get A minus 1. We already have ones. Subtracting ones we can get zeros anyways. But how to get A minus 1? There are infinite ways theoretically to solve any question. So here we start with this minus this. or we can do this minus this and we'll have zeros. So let's change r1 to r1 minus r2 and r2 to r2 minus r3. Left hand side, this is r1 changes, r2 changes, no change in elements of the third row. Let's write elements of the third row first. r1 minus r2 is a square minus 1. This is a minus 1 and this is 0. Similarly, r2 minus r3, this will be 2a minus 2. So 2 into a minus 1. A minus 1 and this is 0. We can take a minus 1 common from first row, a minus 1 from second row. So it's a minus 1 whole square. This will be a plus 1. 1 here, 0 here, 2, 1 and this is 0. This one is 3, 3 and 1. Now the third column has two zeros. So we expand along elements of the third column, C3. This is a minus 1 whole square into 1. Then this is a plus 1 minus 2. This is a minus 1 whole square into a minus 1, which is a minus 1 whole cube. This is what we wanted to prove. The next one. We are given f of x is this. We have to find value of f of 2x minus f of x. So let's write f of x. This is determinant. This is 0. Ax, this is a minus 1. Ax square, ax and this is a. This is a, this is ax. We can have 0 here if we subtract x multiple of first row from this. Similarly, we can have 0 here if we subtract x multiple of this from this. So how do we write it? We write r2 changes to r2 minus x times r1 and also r3 minus x times r2. Let's write, this is no change in elements of the first row. We write elements of the first row. Then this minus x times this is 0. This will be a plus x. This is minus 1. This minus x times this is 0. This minus x times this will be 0 and this is a plus x. Now if we see elements of the first column, we have zeros, two zeros, and elements of third row, again there are two zeros. So we expand along elements of the first column. This is expanding along C1. This will be a and is this minus this. It's a plus x whole square. So this is f of x. We want f of 2x minus f of x. So f of 2x is a into a plus. Now replace x by 2x. This is a plus 2x whole square. Let's find out f of 2x minus f of x. That's a into a plus 2x whole square, a into a plus x whole square. Taking a common is a plus 2x whole square minus a plus x whole square. And then using a square minus b square, it's a plus b into a minus b. That's a into, this is 2a plus 3x. A will cancel out, this is x. So it's ax into 2a plus 3x. This is your answer. Let's discuss another question. This is, we have to evaluate this determinant. 10 factorial, 11 factorial, this is 12 factorial. 11 factorial, this is 12 factorial, 13 factorial, and so on. So we can write elements of first row. We can write 11 factorial as 11 into 10 factorial and 12 factorial as 12 into 11 into 10 factorial. Similarly, elements of the second row and the third row. So what is this equal to? This is 10 factorial. This is 11 into 10 factorial. Then 12 into 11 into this is 10 factorial. Similarly, 11 factorial, this is 12 into 11 factorial, 13 into 12 into 11 factorial. 12 factorial, this is 13 into 12 factorial, 14 into 13 into this is 12 factorial. Let's take 10 factorial common from elements of the first row, 11 factorial from second and 12 factorial from third. So 11 factorial into 12 factorial. Inside it's 1, 11, 12 into 11. Then this is 1, this is 12, this is 156, 1, this is 13, this is 182. Now we have ones. Subtracting ones we can get zeros. So for that, change R2 to R2 minus R1 and R3 to R3 minus R2. This is 10 factorial into 11 factorial into 12 factorial. Elements of first row as it is. This is 0, the 1, and this is 24. This is 0, 1, and this is 26. Now 2 zeros, so we expand along elements of the first column. Expand along first column. This is what we have, 10 factorial into 11 factorial into 12 factorial. Then it's 1 into, it's this and minus this. It's 26 minus 24. It's 2 into 10 factorial into 11 factorial into 12 factorial. This is the answer. Now, coming to the next question. In the next one, we have to prove this determinant is equal to 1. This is 1, this is 2, this is 3. So from this we can subtract twice of this to get 0 here. And from this, from 3 times this to get a 0 here. So let's write left hand side. It's 1, 2, this is 3. 1 plus p, 3 plus 2p. And 6 plus 3p. 1 p plus p, 1 plus p plus q, 3p plus 2q, 1 plus 6p plus 3q. So changing this minus twice of this. So that's R2. R2 minus 2 times R1 and R3 minus 3 times R1. So elements of the first row, where there is no change, we write first. Then this minus twice of this is 0. This minus twice of this will be 1. This minus twice of this, q will cancel out. So this minus twice of this. So that's this minus twice of this is, this will be minus 1. And this is plus p. This minus thrice, this will be 0. This is 6 plus 3p. So thrice of this, p will cancel, we will have 3 here. This will be minus 2 and plus this is 3p. Now we have 2 zeros in the first column, so we expand along elements of first column to get 1, and suppressing this and this, it's this and this. It's 3 here, minus 2 here and 3p here. That's 1 into, it's this product, that's 3p minus 2 and minus this, that will be 3 plus minus this is 3p. 3p will cancel out. So that's 1 into 1, which is 1. This is same as the right hand side. Okay, this is a good question. How to solve it? We have to prove left hand side is 2 times this right hand side. So first of all, let's see how to get 2 here. We add elements of the columns. Right, left hand side. Left hand side is, this is b plus c, c plus a plus b. Then it's q plus r plus p, p plus q. Then y plus z, z plus x, and x plus y. So we write C1 changes to C1 plus C2 plus C3. This will be this plus this is 2 times A plus B plus C. Is P plus Q plus R, and this is 2 times X plus Y plus Z. No change in elements of the second column and the third one. Now take 2 common. We have a plus b plus c, c plus a, this is a plus b, p plus q plus r, this is r plus p, and p plus q, then x plus y plus z, this is x plus y. So if we subtract this from this, we get minus b here. We want b here. Similarly, this minus this will be minus q. We need q here. And also this minus this will be minus c here. We need c. We'll take care of negative signs later on. Let's change second column to second minus first and third to third minus first, so that we have 2 first column as it is. This, minus b, minus q, minus y, minus c, minus r, and minus z. We can take minus signs common, but we need a here. So what we do is we add columns, so that this plus this will be a. We need a here. Changing c1 to c1 plus c2 plus c3. This plus this is a, this will be p, and this is x. Second column, no change. Third column, same, no change. Now take minus 1 common from C2 and C3. We take minus 1 common from C2 and C3. This is what we have. This is 2 times a, this is p, x, minus 1 whole square. This is b, q, and y. This is c, r, and this is z. This is same as the minus 1 whole square is plus 1. Same as this. Okay. For the next one, there are 2 parts. First of all, let us write the given determinant. The determinant is with the elements a, b, c in the first row, b, c, and a. Then we have c, a, and b. We want to prove a plus b plus c is a factor. Adding columns, we get a plus b plus c. Rows, we get a plus b plus c. We can do anything. Add rows or columns. So let's change r1 to r1 plus r2 plus r3. This will be a plus b plus c and a plus b plus c. This is b, c, and a, then c, a, and this is b. Taking a plus b plus c common. This is b, c, and a, and c, a, and b. So subtracting ones. Okay, we have already proved a plus b plus c is a factor. So this proves a plus b plus c is a factor. Now to prove the second part, we need value of the determinant is always negative. Let's see how to do it. We change c1 to c1 minus c2 and c2 c2 minus c3. c1 minus c2, 1 minus 1 is 0, c minus a minus b. Two zeros we expand along the first row. We get 1 into this product, which is AB minus AC minus B square plus BC minus C minus A whole square, which is C square plus A square minus 2AC. That's A plus B plus C minus B square plus BC minus C square minus A square plus 2AC. This is A plus B plus C. A square, okay, we take minus sign common, minus 1, it's A square plus B square plus C square, and then it's minus AB minus BC minus CA. Minus sign here doesn't mean it's negative, because A plus B plus we understand is positive because A, B, C are positive. But we do not know a sign of this. So what we do is, next, we multiply and divide by 2, this expression. So it's minus 1 into A plus B plus C divided by 2, inside multiplied by 2. 2A square, 2B square, 2C square. This is minus 2CA. This is minus A plus B plus C upon 2. And what is this? This is, we can write A minus B whole square, B minus C whole square, and this is C minus A whole square. Now, being squares, sum of squares, this expression is positive. So, this is positive. A, B, C are positive, so A plus B plus C is also positive. Now multiplied by negative sign, so you can say it's negative. This is how you prove it. Now coming to the next one. This is, we have to prove B square plus C square, AB, AC, then BA, C square plus A square, BC. This is 4A square, B square, C square. So what we observe is that we have mixed elements. Mixed in the sense we have product of AB, AC and CB, and also we have squares. We have squares of these expressions. So what we do in such questions, we start from left hand side. B square plus C square, this is AB and this is AC. BA, this is C square plus A square, this is BC. This is CB and this is A square plus B square. So in such questions where we observe mixed elements, we make these changes. We change R2 to R1 into A. We'll divide outside by A. Second row we multiply by B. Third row we multiply by C. Outside we'll divide. So 1 by ABC. This is A into B square plus C square. A square B, A square C. B square A, B into C square plus A square. This is B square C. C square A, this is C into A square plus B square. This is 1 by ABC. Now take A common from elements of first row B from second, C from third. So we write A, B, C outside. This will be B square plus C square, B square, C square. A square, C square plus A square. This is B square, A square plus B square. So what we observe is that we are left with elements with squares only. In the final answer we have squares only. So this is what happens when we observe this and we do this. Next step is we can't expand. That is for every question. We have to bring zeros. So if we subtract from this element sum of these two, we get a 0. Let's do that. R1 changes to R1 minus sum of R2 and R3. We'll have 0 here. Okay, this minus this is minus 2c square, and this is minus 2b square. Then b square, c square plus a square, this is b square. This is a square plus b square. We need 4, so we take 2 common. This is minus c square minus b square. This is c square plus a square. Then c square, a square plus b square. We can have more zeros. Let's see how. This plus this will be 0 here. This plus this will be 0 here. So we will have 1, 2, 3 zeros in the determinant. After that we can expand. So let's do. Change R2 to R2 plus R1 and R3 to R3 plus R1. This is 2 outside, 0 minus c square minus b square. This is b square, a square, this is 0. This is 0 and this is a square. So 3 zeros, let's expand. This is 2. This is 0. Then minus c square is plus c square into it's this minus this. It's a square b square minus 0. Then it's minus b square. This is 0 minus a square c square. That's 2 times. It's a square b square c square plus a square b square c square. Or this is 4 times a square b square c square, same as the right hand side. Okay,